Now we will see classification of embedded system. Embedded systems can be classified based on different criteria like based on generation, complexity and performance requirements, based on deterministic behavior, based on triggering. So we will see these three later. Now we will concentrate only on based on generation. In the first generation, 8-bit microprocessors like 8085 and Z80 and 4-bit microcontrollers were very popular, and it was able to perform simple tasks using assembly code like distant telephone keypads, stepper motor control units, etc. In the second generation, these embedded systems were improved. Instead of 8-bit, we now have a 16-bit microprocessor and a 8 or a 16-bit microcontrollers. The number of bits doubled. The instruction set of the second generation processors or controllers were much more complex and powerful than the first generation. Now they were able to perform little bit more complex operations, especially in data acquisition systems, SCADA systems, etc. In third generation, much more advancement took place and the processors were now 32-bit and microcontrollers of 16 bits. And further complex operations like digital signal processing, application specific integrated circuits came into picture. The instructions became much more complex and powerful, and the concept of pipelining was introduced. Because of pipelining, the performance was improved a lot. Processors like Intel, Motorola, etc. gained high attention because of their high performance. Now, in the fourth generation, system on chip SoC, reconfigurable processors and multi-core processors are bringing high performance, tight integration and miniaturization into embedded device market. With system on chip concept, integration between various functionality with a processor has become easy, and fourth generation chips are used in our smartphone devices, mobile internet devices, etc. So next is the processors are expected to become highly dynamic and demanding, much more faster, much more better.